Today we'll talk about how to graph ellipses, and let's look at the definition of an ellipse. So we can just put, if you put, hold these points down at 0, 0, and 4, 0, these would be the foci, and then if we graph it or draw using this string, then it will make all of the points the sum of the distances to each point on the ellipse will be always the same because we're using one length of string. So a point on the ellipse has a distance to one focus and a distance to the other focus. And we could call this D1 and this is D2. Well, if we drew the ellipse and we had another point over here, then we would say D1 plus D2 is always the same because the length of the string is always the same. That's just a way to draw an ellipse, and there's the definition of an ellipse. Now let's look at the standard form, x minus h squared over a squared, y minus k squared over b squared equals 1. The center is at hk, so we have the center is between the two foci, and we have this relation with the foci. The distance to the focus, c, the distance to the focus, c squared equals a squared minus b squared, where a and b come from the denominators. And a is under the x, so that's a horizontal distance to the vertex, to a point on the ellipse. From the center to the ellipse is a. We could go in each direction, and here b is under the y, so that's a vertical distance, and that will be the distance from the center to a point on the ellipse. And one more thing is called eccentricity, and that is a measure of how far away from a circle the ellipse is. The eccentricity is the distance to the focus divided by the distance to the ellipse. If the focus were at the center, then the distance to the ellipse would be the same as the distance to the focus. No, that's off. Anyway, eccentricity is a measure of how stretched out the circle. If you stretch a circle, then it would be an ellipse. Eccentricity is a measure of that. So this is not in standard form. We would want to divide by 4. Why don't we put a 1 there? Oops, we don't want to divide by 4. We want to have a 1 there. We don't want to have a 1 there. So let's divide by 36. Alright, so we need to have a 1 there, and we're going to divide by 36. So it's over 36. We have 4 over 36, and we'll reduce that to 9. So this tells us that A equals 3, B equals 6. And if we know that, we can also do C squared equals, and in this case we have to do the 6 first. Alright. We always put the larger number first. If we have A and B, one of them will be larger, and then we can always put the larger one first. So now we're ready to graph. There's no horizontal shift, so the center is at 0, 0. 3 came from the denominator of x, so this is the horizontal distance. 6 came from the denominator of y, so that's a vertical distance. And we have the ellipse. We can graph the foci with this. This is a little beyond 5, so I can just move up to a little beyond 5. There's a focus. A little beyond -5, there's a focus there. This is the major axis, and this is the minor axis. This is a vertex, and that is a vertex. These are foci, and this is the center. When we write out the coordinates of the foci, we could say 0, and then it's up radical 27. Oh, let's not write radical 27. Let's write 3 radical 3. 0, 3 radical 3, and also 0, -3 radical 3 for the foci. And we can see all the other parts of the graph too. Pause the video and try that one. We're going to move left 5, up 1. And then we're going to move 2 vertically. We're going to move 3 horizontally. And then let's find the foci. C squared equals 3 minus 2. 3 squared minus 2 squared. 9 minus 4. C is radical 5. And let's go ahead and look at eccentricity is C over A. So that's square root 5 over. And it has to be, when this says A, this is one of the confusing things about these formulas. A is always the larger denominator. So there's the eccentricity. Let's look at the coordinates of the foci. This is between 2 and 3. So we're going to go 1, 2, somewhere between 2 and 3. 1, 2, somewhere between 2 and 3. And the foci are going to be 1, 2, 3, 4, 5. The center is 1, 2, 3, 4, 5, 1. Negative 5, 1. But the foci, we could write them like this. We're going to do negative 5 minus radical 5. So we're starting at negative 5 and going negative radical 5 up 1. And we can also do negative 5 plus radical 5 up 1. So we go negative 5 plus radical 5 will take us to that focus. Negative 5 minus radical 5 takes us to that focus. Alright, so try that problem. And remember, you have to divide by 36. Pause the video and try that. So here we have, call that B. A is 6. And there is no translations, so the center is at the origin. Then horizontally we move 2, vertically we move 6, and the foci C squared equals, let's do 36 minus 4. And that's a little under 6. 1, 2, 3, 4, 5. So the foci are up there and down there. The coordinates of the foci would be the x value is 0, and then up 4 radical 2, and 0 down 4 radical 2. The eccentricity is C over A, 2/3. We just have to put this in standard form before we graph it, and we'll complete the square. But before we do that, we need to look at this because that's not a 1. Alright, we factored out the 4. Now we can do half squared, 9, 9. Half squared, 1, 4, because this has a value of 4, we have to subtract 4. Nine minus 9, and it'll just be a minus 4. Move the 4 over, and then divide by 4. Now we're back to what we've been doing, and we can find the center, left 3, up 1. Horizontally, because it's under the x, we're going to move 2 horizontally. The 1 is under the y, so we're going to move 1 vertically. This is 2 squared minus 1 squared. And that's about 1.7, so we'll go 1.7 here, 1.7 there. Those are the foci. Eccentricity is c over a is 2. The foci are the y value is 1, and then we're going to have negative 3 plus radical 3 and negative 3 minus radical 3. The vertices are 1, 2, 3, 4, 5, negative 5, 1, and negative 1, 1. Last example. Okay, pause the video and try that one. So, we're going to add 1. We're going to write a 1, but it has a value of 4, so we subtract 4. This is negative 16, so we're going to add 16 and divide by 16. And the center will go right 1 and down 2. The horizontal distance is 2. The vertical distance is 4. And the distance to the foci is c squared, 16 minus 4. And we could say that, well, that's about 3.5. So 1, 2, 3.5. 1, 2, 1, 2, 3.5. So the foci, this point is over 1, and then it's going to be, we could start with this, which is negative 2 plus 2 radical 3, negative 2 plus 2 radical 3, and then it'll be negative 2 minus 2 radical 3. Coordinates of the foci, eccentricity c over a. A is 4. It's going to be the square root of the larger denominator. And the vertices are 1, 2, and 1, 1, 2, 3, 4, 5, 6. 1, negative 6. And we'll stop there.